Okay, example 7, find a polynomial function degree 4. So once again, we're trying to do a polynomial function. It's got a specific degree 4, so that means we need 4 answers. They've given us 2. Has real coefficients. This is important. If it has real coefficients, that means if a complex number is an answer, then its conjugate is also an answer. And that's what they've done for us, is they've given us a complex answer, 2i. They've actually given us a second complex answer, 3 minus 7i. So if 2i is an answer, that means also negative 2i is an answer. And if 3 minus 7i, then 3 plus 7i. Okay. So in every answer you're going to get in this lesson is going to be real. It's going to have real coefficients. So if you do get conjugates, expect the, or I should say if you have complex numbers, you expect the complex conjugate also to be a solution. So there's 4 zeros, so we're ready to go. The zeros are all imaginary. So if I write this out, p of x equals, I'm going to do the conjugate pairs in different colors, so I'm going to do these in red. So I'm going to do x minus 2i and x plus 2i. If there's no real number attached to the complex number, then it's just the conjugate, just the opposite signed I thing. So minus 2i plus 2i. And I'm going to do the other two. I'll do them in purple since I already got them in purple. So it's going to be, the top one's going to be x minus 3 plus 7i. The bottom one's x minus 3 minus 7i. And I just decided to use the color of the purple because that blends in with the red on video. Let's go black, red and black. All right. So what I'm going to tell you is this. I can multiply this in any order I want to, but if I multiply the conjugate pair factors together, I'll get reals. So if I multiply these two red ones, I'm going to have all real coefficients right then. Multiply these together, I'll have all real. If I multiply this and this, I'm going to still have imaginary sticking around. So it's a little uglier. All right. So the advantage, well, there's no advantage. I was going to say the advantage is we can do it twice, but they're different. So yeah, there's no advantage to doing it that way. So don't do it that way. Whatever conjugate pairs factors are, do those first. So this is just a basic FOIL on this one. X times x is x squared. I'm going to get plus 2ix and minus 2ix cancel. And minus 2i times plus 2i makes plus 4. Be careful, that actually makes negative 2i squared. Remember from algebra 2, I squared equals negative 1. Oh. Right number there, 4. All right, that makes negative 4i squared. I squared is negative 1. Negative makes a positive. So when you're multiplying those out, that's what happens. Now this other one's a little bit more complicated, so this is one I'd be more careful of, and maybe even do it on a scratch sheet of paper and just transfer your answer down here will be fine. All right, but if I multiply this out, in fact, let me just take this to a scratch sheet of paper, copy, paste. All right, so if I do x times all this stuff, I'm going to get x squared minus 3x minus 7ix. If I do negative 3 times all this stuff, I get minus 3x. I get plus 9. I don't have any real constants yet, so I make a new column there. And minus 3 times minus 7i makes positive 21i. I don't have anything like that either yet. I have an ix, but not just an I. So I'm making new columns as I get new things. And then if I do the last one, 7i times all that stuff, I get plus 7ix. I can put it right under the minus 7ix. I get minus 21i, put that underneath the plus 21i. And I get plus 7i minus 7i, which makes minus 49i squared, also known as plus 49. Okay, and it's not as elegant as some of these other column multiplication type things we do, or like when we make up these like nice columns here. But what should happen when you're doing these complex conjugate factor multiplications, you're going to get 4 imaginary terms every time, but they're going to be opposites of one another. So 7ix and negative 7ix cancel, plus and minus 21i cancel. The only other imaginary piece is right here with I squared, but that changes to a real number. So you're going to end up with 5 real number objects. So we get x squared minus 6x plus 58 is the product of those two things, which then I will take that guy and bring it back over to my actual paper. This is a space saver to some extent, but it's also, you know, you guys know how to do this multiplication, but if you try and do it within the problem that you're working on, it gets all jumbled up sometimes and it makes a big mess. So again, get a scratch sheet of paper for this assignment, do all that kind of stuff over there somewhere, just bring it down. All right, so This makes this, this makes this. Then, at this point, we got all reals. Now it's just a matter of doing that same thing we just did on the last page here. At this point, that's all that's left to do, and it's all real, and it's going to be more the elegant type where like terms line up and everything. So x squared times all this makes x to the fourth minus 6x cubed plus 58x squared. And if I do this times all this, I'm going to get plus 4x squared, lining up with 58x squared, minus 24x, and then plus 232. So x to the fourth minus 6x cubed plus 62x squared minus 24x plus 232. P of x equals. This is also checkable, but it's a little bit more complicated to check it on your calculator. Let me show you how to do that. Let me fix that 2 first. Looks like 23 squared, 232. There we go. All right. Here's how you check it on your calculator. Alright, so what I'm going to do is I'm going to type in this. I'm going to type in 2I store x. If it's an imaginary, you can't put imaginaries in the table. It doesn't like that. So 2I store x. So what you're doing now is telling the calculator, anytime I hit the x button, it's 2I. And then I'm going to put in a colon, which is alpha this thing. And then I'm going to type in my function x caret 4 minus 6x caret 3 plus 62x squared minus 24x plus 232. And it should equal 0. Boom. Alright. If I hit second entry, it brings up the exact same thing I did. If I insert a negative sign, also works. I should have known that also works because I have all real coefficients, and 2i works, so its conjugate should work. If I hit second entry again, go up here and insert a 3 minus, so 3 minus 7i, enter, uh-oh, minus, not negative 7i, 3 minus 7i. Now, that says negative 3e negative 10.
Which is like near 0.
Negative 3e negative 10 means negative 0.00000000003, better known as 0. All right, basically there's a rounding issue in there. The numbers got to be so large that it created a little decimal error in there. So if you see e negative like 5 on up, negative 5, negative 6, negative 7, it's close enough to 0, you can just say it's 0, you're right. And then of course if 3 minus 7i worked, then of course 3 plus 7i should work, but just to verify, okay, same thing. The reason I like to type it in like that way when I hit second entry, I just have to change x. I don't have to keep on typing in my polynomial function every time. So again, if you store x, colon, then type in the function you're trying to evaluate, that's how I would check imaginary roots if I want to verify the correctness of my polynomial. It is degree 4. All 4 of these things created a value of 0 to the function. Everything that I was supposed to do is done. So that's the right answer.